Have you ever really thought about all the invisible systems that are working right now to keep you safe inside whatever building you're in? Well, today, we're going to peel back the walls and take a look at these hidden guardians, the ones that stand between us and a fire. And trust me, the engineering behind it is seriously cool. Okay, so let me ask you this. When you think of a building fire, what's the first thing that comes to mind? Flames, right? The heat. But what do you think is the real killer? What's the thing that's actually the most dangerous? It's the smoke. And this number right here, 79, it tells a really tragic story. That's how many people died from smoke and toxic gas during the massive fire at the MGM Grand Hotel back in 1980. And here's the crazy part. The fire itself, it was mostly stuck on the first floor. But the smoke, its deadliest product, it went everywhere. So to really get how we fight this invisible threat, we've got to look at some of the tough lessons from the past. Lessons that taught us something terrifying. In a fire, the very air you're breathing can become the thing that kills you. You can really see the evolution of fire safety just by looking at these two disasters. So you go back to 1911, the Triangle Shirtwaist Factory fire. The big problem there was just getting out. I mean, workers were literally trapped by locked doors. It was about physical escape. But then you jump forward to 1980, to the MGM Grand. It's a totally different story. The danger wasn't about not having exits, it was about the air itself. The fire was way down on the ground floor, but the smoke, it just crept silently up through the building, and that's what made the upper floor so deadly. And I mean, just look at these numbers. It's staggering. 93% of the deaths at the MGM fire were from smoke and toxic gas, not burns. The fire's on one floor, but the smoke just billows up through elevator shafts, vents, you name it, basically turning the upper floors into death traps. This was a massive, brutal wake-up call for everyone. It became crystal clear that just stopping the flames wasn't enough. You had to stop the smoke. So, how do you fight an enemy that can travel through the air completely unseen? Well, this is where engineers and architects got really clever. They came up with a new strategy. What if, instead of one giant open building, you build a bunch of smaller, protected fortresses inside of it? And that strategy is called compartmentalization. It's a bit of a mouthful, but the idea is super simple. You build fireproof boxes inside the building. The whole goal is if a fire starts in one of those boxes, you keep it trapped right there. You contain the flames, and just as important, you contain the smoke. Right, but these fortress walls, they're not your average drywall. Not even close. They're actually entire systems. We're talking special studs, insulation, layers of fire-resistant material, the whole shebang. They're all tested to hold back a fire for a specific amount of time. It's like a time shield, right? It's buying you precious minutes, maybe even hours, for people to get out safely. And not all these walls are created equal. There's actually a whole hierarchy of protection. So at the very top, you've got the big guns, firewalls. These things are the absolute strongest. They're designed to stay standing even if the building around them collapses. Then, a step down, you have fire barriers and shaft enclosures. These are like the inner defenses of the fortress. They're what separate floors or protect really important things like stairwalls. And then finally, you have fire partitions, which are the lightest duty walls, often used to separate individual rooms or hallways. Each one has a specific job in this grand strategy of containment. Okay, so this all sounds great, right? We've got these awesome fireproof boxes, but there's a problem. What about all the holes we need to poke through them? You know, for air vents and ducts. The very system that gives us fresh air could easily become a superhighway for smoke and fire. I mean, that's the Achilles heel, isn't it? How do you keep your fortress walls secure when you have to punch a huge hole right through it for the air conditioning? Well, allow me to introduce the hero of this entire story, the fire and smoke damper. This little device is the guardian hidden inside the ductwork. The best way to think of it is like an automatic gate. Normally, it's open, letting air flow like it's supposed to. But the second it senses danger, bam, it slams shut, sealing that hole in the wall and stopping the threat in its tracks. And there are basically two main types of these guardians. You can think of it as the brawn and the brains. The fire damper, that's the brawn. It's super simple. It has this little metal link that's designed to melt when it gets too hot. When it melts, the damper snaps shut. Its job is to stop the flames. Then you have the smoke damper. This is the brains of the operation. It's wired into the building's smoke detectors, and it closes the very instant smoke is detected. This one is all about stopping that silent killer we talked about. And the engineering here gets even cooler. They have something called breakaway connections. So the way the duct is attached to the damper is actually designed to be the weakest point. Why? Well, think about it. In a huge fire, that metal duct could get super hot, start to twist, and collapse. You don't want it to rip the whole damper right out of the wall, right? That would breach your fortress. So instead, it just breaks away cleanly, leaving the damper in place to do its job. So you might be wondering, who makes sure all of this actually gets done right? It's not just one person's job. It's actually a whole chain of command, a whole team of professionals, all working from the same blueprint for safety. It really boils down to a 4-step process. First up, the architect designs the building and marks out where all these special fire-rated walls need to go. Next, the engineer comes in and does the detailed work, figuring out exactly what kind of damper is needed for every single opening. Then you have the manufacturer, who has the huge responsibility of actually building and testing these things to incredibly strict safety standards. I mean, people's lives are on the line. And finally, you have the code official. They're the inspector who comes in at the end, checks everything, and makes sure it was all installed perfectly, just like the plan said. And this is the part where there is absolutely no wiggle room. You have to follow the manufacturer's instructions perfectly. This quote from the safety standards says it all. Anyone who requires or does any change not specifically shown or defined by the manufacturer is not in compliance with the as-tested UL safety label of that fire or smoke damper. Period. They're not kidding around. You aren't just slapping in a piece of metal, you're installing a life-saving device that was tested to work in one very specific way. But here's the thing, just installing these systems is only half the job. To make sure they'll work when you need them, they have to be checked and maintained. This is where ongoing vigilance comes in. Yeah, this isn't a set it and forget it kind of thing. There's a whole schedule. 1 year after they're installed, every single damper gets inspected and tested. After that initial check, it's every 4 years for most buildings. In hospitals, where safety is even more critical, it's every 6 years. The point is, someone is making sure these things are always ready to go. So really, the big takeaway here is that these systems are all around us. They're in pretty much every office, hotel, school, or hospital you've ever been in. They are a core part of what makes modern buildings safe, just silently waiting in the walls and ceilings, standing guard. So the next time you're in a building and you happen to look up at a ceiling vent, you'll know what's really hidden inside. It's more than just a vent. It's the post-first silent guardian, waiting to save your life. And that kind of makes you think, doesn't it? What other invisible systems are out there, keeping us safe every single day?